Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 31. The positions of shafts A and C are fixed while that of shaft B can be varied via vertical slot and the locking bolt, which is this. If the coefficient of static friction is mu at all interfaces, determine the dependence of T on the coordinate y, where T is the tension required to begin the cylinder of mass m. So this is the tight tension T and the slack tension would be on this side mg. All shafts are fixed against rotation. If the coefficient of static friction are as follows: zero point 0.6 at A and C and zero point 0.2 at B, determine the value T over mg for y equals 0, y equals 5r, and y equals 10r, where r is the common radius of all three shafts. What are the limiting values of T over mg for y equals 0 and for large values of y? So for the solution, let's have the relationship between tight and slack tension. Tight tension equals slack tension A to the mu sub s beta. Let's call the angle of inclination of this side of this cable or cord or belt with respect to the horizontal as theta as shown. Then the angle that the vertical and the radial line to the point of contact here would also be theta. So this is theta, this is theta. Therefore, the total angle of contact at B for this position in general is 2 times beta. While the angle that the horizontal line and the radial line to the point of contact make with each other is theta as shown. So the vertical, so this is 90 degrees minus theta. The angle of contact between or the angle between the horizontal and the radial line to the point of contact is 90 degrees minus theta, because the angle between the radial line and the vertical is theta. So this is 90 degrees minus theta. This is also 90 degrees minus theta. Therefore, the angle of contact at A is equal to that at C, and it is 90 degrees minus theta. The total angle of contact, therefore, for this general position is 2 theta plus 2 times 90 degrees minus theta, which simplifies to just 180 degrees or pi. We then substitute into this equation where the tight tension is T, the slack tension is M times G, then e to the mu sub s beta. So that's the answer to the first part. Then in the second part, if the coefficients of static friction are as follows, so we'll have different coefficients of static friction for A and C and at B. So let's have it in general. So we have to call this tension 1, here tension 2, and tension 1 equals mg e to the mu sub s c times beta c, which is 90 degrees minus theta, to be converted in radians. So beta a equals beta c equals 90 degrees minus theta in this position in general, and beta b is equal to 2 theta as shown. So tension 1 equals mg e to the 0.6 of beta c, because the coefficient of static friction for A and C is 0.6. Then T sub 2 equals T sub 1, which is this expression here, this value here, e to the 0.2 of beta b. So T sub 2 equals T sub 1 e to the 0.2 of beta b. So substitute T sub 1 is mg quantity e to the zero point 0.6 beta c, then times e to the 0.2 beta b. So combining, T sub 2 equals mg e to the zero point 0.6 beta c plus zero point 0.2 beta b. Then T2 and T, this is the tight tension. So T equals T2 e to the mu, mu sub A, which is zero point 0.6, then beta A. So since this is T sub 2, you just copy it from here. Then we have to multiply it by e to the zero point 0.6 beta B. Remember that beta A and beta A and beta C are equal, so we can combine and make it zero point 0.6 beta A, zero point 0.6 quantity beta A plus beta C, or simply 1.2 beta A. So T equals mg e to the zero point 0.6 quantity beta A plus beta C plus zero point 0.2 beta B. Then combining, because beta A equals beta C, equal to 2 theta, or in general equal from here 90 degrees minus theta to be converted in radians. So T equals mg e to the 1.2 beta A plus zero point 0.2 beta B. So this is our general expression or formula for T. Then we then evaluate the ratio T over mg for y equals 0. So define theta first. Tangent theta equals y over 3r. So if y is 0, theta is 0. So that means these three cylinders will be on the same horizontal plane. That's why the chord at B, or the belt at B, is tangent. So there's no angle of contact at B if the bolt is here, or cylinder B is on this level, same levels as A and C. But 90 degrees minus theta, because theta is 0, is 90 degrees. So pi over 2 also at C. So y is 0, theta is 0. Therefore, beta A equals beta C equals pi over 2. So this would be the cable or the belt when y is 0. So beta A equals beta C. So this is the point of contact, tangent, horizontal, is pi over 2. And beta B is 0 for that, because it is just tangent at the top when the cylinder B is at the same level as that of A and C. So substitute into this equation. Take note that beta A is pi over 2, beta B is 0. So T over mg equals e to the 1.2 of pi over 2 plus 0, 0.2 times 0. So we can evaluate that ratio, and it is equal to 6.586. Then when y is 5r, so tangent theta is 5r over 3r, arctan of 5/3. So theta equals 59.036 degrees, arctan of 5/3, when y is 5r. Then we convert this to radians. So beta b is 2 times 59.036 degrees times pi over 180. I'm not showing it here. So beta a is 90 degrees minus 59.036 beta a, which is equal to beta c. And in radians, 90 minus 59.036 degrees times pi over 180. So it's 0.5404. Beta b is 2 times theta, 2 times 59.036 times pi over 180, so 2.0607. Then we substitute it into this equation here. So T over mg equals e to the 1.2 of 0.5404 plus 2.2 of 2.0607. So using your calculator, T over mg equals 2.888. Then when y is 10r, theta is arctan of 10 thirds, and that's 73.301 degrees. Then beta A is 90 minus 73.01 degrees times pi over 180. That would be equal to, in radians, 0.915. And beta B, which is 2 times 73.301 degrees, 2 theta times pi over 180, is 2.5587 radians. We then substitute into this equation here. T over mg equals 1.2 of 0.2915 plus zero point 0.2 of 2.5587. So T over mg when y is 10R is 2.367. Then to answer what are the limiting values of T over mg for y is equals 0 and for large values of y, when y equals 0, this is the value. T over mg is 6.586. Then when y is infinite, so meaning to say it's very far from here, so the cable, this cable here, will be tangent to this. So 90 degrees minus theta would be 90 degrees minus theta would be 0, and the value of theta approaches pi over 2, because tangent of theta is very large over 3 is very large. Inverse tangent of very large is 90 degrees or pi over 2. So when y approaches infinity, theta approaches pi over 2. So I hope you can anticipate that. You just substitute very large value here, or you look at the figure when B is very far, then this chord will almost be vertical. So that's why theta is pi over 2. Then beta A equals beta C would be 0. Beta B would be 2 times pi over 2, and it is pi. So beta A approaches 0, beta B approaches pi. Therefore, the T over mg would become T over mg would become, since only B will be in contact with the cable or the belt, then this part beta A would be 0, and this is in general mu sub s of cylinder B and cable and or belt, and this is beta B, which is pi. So T over mg equals e to the mu sub b times pi. So I hope that you understood it. Beta b approaches pi, beta a is 0, and therefore, since this is the only part where the belt is in contact with the cylinder, and it is cylinder B, beta a and beta c 0, so that would be the limiting value of the ratio T over mg when y approaches infinity. Level 32, bucket A and block C are connected by a cable that passes over drum B. Knowing that drum B rotates slowly counterclockwise and that the coefficient of friction at all surfaces are mu sub s 0.35 and mu sub k 0.25, determine the smallest combined mass m of the bucket and its contents, for which block C will remain at rest, B start moving up the incline, and C continue moving up the incline at a constant speed. So let's analyze it well. It's a bit challenging problem. So for the solution, relationship between tight and slack tension equals slack tension e to the mu beta. This mu here may be mu sub s or mu sub k depending on the situation. So for part 1, let's do the free body diagram. First, this one, 100 times 9.81 is 981 newtons. Then the normal, which makes an angle with the vertical of also angle of inclination 30 degrees. And therefore, the friction will depend on the information and condition here. So I'll just put it up or right, downward, upward or downward. And it is mu. It may be mu sub s or mu sub k times n sub c, depending on our analysis here, which will be explained later. So since the couple applied is for this to move is to rotate this in this manner, counterclockwise. Therefore, by principle, this should be the tight tension for all cases. And this is the slack tension, T sub S. So the angle of contact between the cable and this drum here is 90 degrees plus angle of inclination 30, so 100. This is 30 degrees angle between the vertical and the radial line to the point of contact is also the angle of inclination 30 plus 90, 120 degrees, and that is 2/3 pi radians. So beta is 2/3 pi radians. So for the first part, determine the smallest combined mass of the bucket. So we apply this equation. T sub S is 9.81 of m. T sub T is uh, will will we will define T sub T based on this free body diagram here, so that the value of m and its contents will be minimum as possible. So when the drum is rotated, that can be in equilibrium if there is slipping between the drum and the belt here, but it will just be to develop this tight tension here in such a way that this still remains in equilibrium. So since this remains in equilibrium and there is supposedly slipping here, the coefficient of friction to be used here is mu sub k, while here, because this is not moving and there is only slipping between the belt and the drum here, so here it's not, it remains at rest, then the coefficient of static friction should be used here. So from the figure, summation forces normal equals 0, n sub c is 981 cosine 30 degrees. So n sub c is equal to 849.571 newtons. So if this remains at rest and motion T sub t is developed in such a way that it will just hold this at rest, take note we are computing for the smallest combined mass m of the bucket and its contents, so motion should be impending downward. Then if it is impending downward, friction should be upward. So summation forces tangential equals 0, T sub t plus 0.35 coefficient of static friction, remember this remains at rest, times normal equals 0. Then minus 981 sine 30 degrees. So T sub t, upward, motion is impending downward, so plus friction 0.35, 849.571, coefficient of static friction because this remains at rest, times 849.571, then minus the component of 981 in that direction, 981 sine 30 equals 0. So T sub t equals 193.15 newtons. Then between T sub t and T sub s, which is T sub s 9.81 of m, so imagine that there is slipping, or the belt slides when the drum is rotated, but that is just enough to maintain equilibrium of the right side and the left side, or tight side and the slack side. So the coefficient of friction to be used in this relationship here is 0.25, because if there's no slipping here, then this crate here will start to move up, as well as this one. This will go down. So just enough for the system to be in equilibrium, so there is slipping here, 0.25. So T sub t, 193.15 equals m times 9.81 e to the 0.25 of angle of contact 2/3 pi. From there, we can solve for m, and m is equal to 11.66 kilograms. In part B, the smallest combined M of the bucket and its contents to start moving up the incline. So there is impending motion up here, but this remains at rest, but friction is now going down. Then here, because the only way this block will start to move up is there should be no slipping here, or else this remains at rest and it tends to slide down. So for this crate to start moving up, there should also be no slipping between the belt and the drum at B. So that for this relationship later, this is now 0.35 mu sub s. Beta is the same. Then for this crate here, because this tends to move up, to start to move up, then friction is going down. So T sub T will now be summation versus tangential T sub T, then minus 0.35 of 849.571 minus 981 sine 30 degrees equals 0. So T sub T is equal to 787.85 newtons. Then we substitute into this equation. Take note that there should be no slipping between the belt and the drum here. So we use mu equals mu sub s equals 0.35 in that relation. So 787.85 equals 9.81 times m e to the 0.35 of 2/3 pi. From there, we can solve m, and m is equal to 38.59 kilograms. Then finally, uh, to continue moving up the incline at a constant speed, so that means this one. So there's still no slipping here. So this is intact. So the coefficient of friction to be used here is static friction. And while this one, because this now moves up and it continues to move up, then friction is still going down, but the coefficient of friction to be used is kinetic friction, mu sub k. So T sub T minus 0.25 of 849.571 minus 981 sine 30 degrees equals 0. So T sub T equals 702.893 newtons. Then for this relationship, same, it is 0.35 and beta is 2/3 pi. So 702.893 equals 9.81 m e to the 0.35 pi over 2/3 pi. So m is equal to 34.42 kilograms. Level 33. Blocks A and B have a mass of 7 kilograms, this 7 kilograms, this 10 kilograms respectively. Using the coefficients of static friction indicated, determine the largest vertical force P which can be applied to the cord without causing motion. So since P is the largest vertical force without causing motion, so this would be the tight tension, considering the peg and the cable or rope in this part. So all sides here will be treated the tight tension. So first, let's determine the tension that should develop here so that motion will not occur. So there are two possibilities for the motion of B, and one is by sliding past block A, or tipping about this point. So the lower value would control, of course, because uh, if you use the higher value, that means the other possibility uh, happens, and that would be in motion already. So for the solution, tension in the tight side equals tension in the slack side e to the mu sub s beta. So let's draw the free body diagram of the upper block B. So since B has a mass of 10 kilograms times 9.81, so 98.1, and the tension here, we'll just call it tension B. Then summation forces vertical, this is also 988.81, and friction maximum is 0.4 of 98.1. So summation force is horizontal equals 0. So zero point 0.4 of 98.1 minus T sub B equals 0. And computing for T sub B, it is equal to 39.24 newtons. That is if slipping between A and B controls or not controls. Then for the second part, the second possibility, this may tip when the force P is applied here to the right, like that. So this will tip about this point. So let's also compute T sub B if tipping controls. Summation moment about this corner here equals 0. So T sub B times 400, counterclockwise positive, then minus 10 times 9.81 times half of 300 is 150 mm equals 0. So T sub B equals 36.788 newtons since this is lower tipping controls. So tipping about this control. So this should be the value of tension at B. Then we analyze A and B. So applying tension at B to determine the tension in AC. So the normal reaction here is 17 because this is 7 kilograms. So let's remove the other forces. So 7 times 9.81. So the total reaction, normal reaction here is 17 times 9.81. And that is 17 times 9.81. Then the maximum frictional resistance is coefficient of friction 0.3 times normal 17 times 9.81. So it should be leftward. So 0.3 of 17 times 9.81, coefficient of static friction times normal. Then call this tension AC. Then let's solve for tension AC by summing forces horizontal. So tension AC minus 0.3 times 17 times 9.81 minus tension B, which is 36.788 equals 0. So tension AC is equal to 86.819 newtons. Having found tension AC, take note that this side would be the tight tension. So tension in CD, let's call that tension CD, equals tension AC 86.819 E to the mu, which is zero point 0.4, beta is pi over 2. You look at the angle of contact here. So tension CD is tension AC E to the mu sub C beta C. So tension CD equals 86.819 e to the zero point 0.4 and beta C is pi over 2. So tension CD is equal to 162.738 newtons. So finally, between P and tension CD, remember this is the tight tension P, then it is equal to 162.738 e to the zero point 0.1 and the angle of contact pi. So P is 162.738 e to the zero point 0.1 times pi. So from there, we can solve for P, and P is equal to 222.8 newtons. So that's it, and I hope that you were able to follow the explanations and the solutions. So it's a bit long for this video. So I end.